Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be dealing with another discrete random variable distribution, which will be negative binomial distribution. Negative binomial distribution. What is negative binomial distribution? Suppose we have x plus r trials. These many trials we are having, and the distribution which tells us about number of x failures before rth success. That distribution is termed as negative binomial distribution. Suppose I am tossing a coin and I have to calculate my suppose I am suggesting that my probability of success is head. If head comes, then I will consider it as p, and probability of failure is q. When q comes, when tail comes, I will consider it as q. So I have to calculate the fifth head. That will be the success. So this R here will be P, and R here will be 5. Success is P and failure is Q, and X here will be, suppose there are 10 trials. So out of 10, 5 are successes and 5 will be failures. So total will be 10 trials. So this is how it is supposed to be. Now if there is a random variable x and it follows negative binomial, which is represented by NB, that has two parameters r and p, then probability mass function of x, r and p can be written as x plus r minus 1 r minus 1 into q raised to the power p raised to the power r into q raised to the power x, where p and q both lies between 0 and 1, and x has values 0, 1, 2 and so on, and r also has value 0, 1, 2 and so on. So this PMF represents our negative binomial distribution and is very important for calculation purposes that we'll be going to do in some of the questions. I hope the concept of negative binomial distribution is clear with all of you. Now moving forward with some of the properties of negative binomial distribution. Properties of negative binomial distribution. The first property will always be mean. So mean of negative binomial distribution is given as RQ by P. If we talk about the variance of negative binomial distribution, then it will be nothing but RQ by P square. If we talk about the third property, which is mod, then that would be R minus 1 into Q by P. These are the three main properties of negative binomial distribution. If we talk about the fourth property, which is MGF, which is moment generating function, it can be represented by mxt, then this is written as p raised to the power r upon 1 minus q e raised to the power t raised to the power r. Or we can also write this as p raised to the power r 1 minus q e t raised to the power minus r. The fifth property is characteristic function, which is also represented as phi xt. It can be written as p raised to the power r upon 1 minus q e raised to the power it raised to the power r is equals to p raised to the power r 1 minus q e raised to the power it raised to the power minus r. And the sixth property is probability generating function of our uh, probability generating function of negative binomial. This can be represented as p raised to the power r upon 1 minus qt raised to the power r, or this can also be written as p raised to the power r into 1 minus qt raised to the power minus r. All of them have similarities, just there is for probability generating function, instead of exponential t it is directly t, and for characteristic function instead of exponential t it is exponential it. Now there is one more property, coefficient of variation. I can write it here only, which will be our property number 7. If we talk about coefficient of variation, this has the formula standard deviation upon mean. Now we know that standard deviation is nothing but under root of variance upon mean. Here variance have been given to us as rq upon p square. So under root of rq upon p square upon a mean rq upon p. When under root comes p square comes out of under root, it will be under root of rq upon p upon rq upon p. So these two p will get cancelled, and this under root rq can be get cancelled by denominator, and we get 1 upon under root of rq as coefficient of variation. This is our seventh property. There is one more property of negative binomial distribution. Eighth property, when we put r equals to 1, then in negative binomial distribution, then our PMF reduces to x plus r is 1 minus 1 upon r minus 1 is 0 into q raised to the power x p raised to the power 1, which is nothing but PMF of geometric distribution having parameter p. So negative binomial distribution having r equal to 1 and the parameter p equal to p reduces to geometric distribution of parameter p when r is equals to 1. This is one of the properties of negative binomial and both geometric distribution. So we can say that geometric distribution is one of the cases of negative binomial distribution. The last property of negative binomial distribution is that if x follows negative binomial of with parameters r and p, then summation I goes from 1 to n iid x size independent and identically distributed also follows negative binomial with summation I goes from 1 to n ri's and p. This is also one of the important properties of negative binomial. So these were all of the properties of negative binomial. Now we'll move forward to the questions of negative binomial distribution. So this is our first question, which states that we have been given two equations, two statements, and we have to answer which one is correct and which one is incorrect. So the first statement says that if x follows binomial n and p, then variance is less than mean. So if x follows binomial with the parameters n and p, then mean of x will be equal to np and variance of x is equals to npq. Now from this equation only, since we know that P or Q lies between 0 and 1. So if we multiply something with 1, so mean into Q is nothing but variance from this formula. And from this, we can state that variance is less than mean, because mean is multiplied by something to get the variance. So variance will be less than mean, because this lies between 0 and 1. Something which is less than 1 when multiplied with some other number makes it lesser than that. So here we can say that variance is less than mean, which states in our first equation that if x belongs to binomial n and p parameters, then variance is less than mean. So first statement is true. If we talk about the second statement, if x follows negative binomial with parameters r and p, then mean. If we talk about mean of negative binomial, it will be r q upon p. And if we talk about variance, then it will be rq upon p square. Now here we can say that p also lies between 0 and 1. So if we talk about mean, if we divide mean by p, then we will be getting the variance. Now here we are dividing something which is less than 1 to fun number. Then if we multiplied it in this binomial distribution, then it was reducing the number. If we divide it with the to the number, then it increases that. So here we will say that variance is greater than mean for this case, because here it is division and there it was multiplication. So if x follows negative binomial with parameters r and p, then mean is less than variance, which we have proved here, and hence this statement 2 is also correct, which is true, and hence both 1 and 2 are correct. Option C is our answer. Now moving forward to another question. Here they have given us the relationships between mean and variances of different distributions. So mean and variances of different distribution they have stated for now only if x follows binomial np, then we stated just before this, the first question was about this, then we stated that variance is less than mean for binomial. Here only we state that. For binomial NNP, variance is less than mean. So first one is this. So if we represent variance by sigma square and mean by mu, then it will be sigma square is less than mu. If we talk about the second distribution, which is Poisson, if x follows Poisson with lambda as parameter, then we know that for Poisson distribution, mean and variance are equal. Mean has the formula as lambda and variance also has the formula as lambda. So both of them are equal. The third distribution is negative binomial distribution. If x follows negative binomial distribution r and p with as its parameter, then just now we did that variance is greater than the mean. Here, if x follows negative binomial with r and p, then variance is greater than mean. So here it is. And if we talk about a distribution which is normal distribution, if x follows normal distribution with mean mu and variance sigma square, then we cannot state any of these kind of relation. So we can say that there is no such relation between them, right? So here we have to match them. So the first is binomial distribution where sigma square is less than mu. So sigma square is less than mu, which is third. So A matches with 3. Then third and first get cancelled. Now Poisson is both are same. Sigma square is mu. So 2 matches with B. B with 2. Then the third one, negative binomial distribution, where mean is less than sigma square. So C matches with 1. And the left one, normal distribution, no equality or inequality relationship between mu and sigma square. So D matches with 4. So the code that matches is A3, B2, C1 and D4. A3, B2, C1 and D4, which is our option number C. This is how, if you know the concept, you will be able to do it within seconds. This I had to explain you, that's why it took so much time. Otherwise, this is the question of just seconds. Now moving forward to another question. This is a direct binomial distribution question. Here they have given us that a player is shooting at a target and the probability of the hit is, that is, they have given us the probability of the hit is zero point 0.3. Then probability that it did not hit is 1 minus 0.3, which is 0.7. The probability that it hits 10th trial, hitting 10th trial means the success, which is 10. Results in the third hit. Okay, results in third hit is the success, so that will be 3. The total trials have been given to us as 10, and the rest, the failures, will be n minus r, which is 10 minus 3, which is 7, which is taken as x according to the theory that we did. So the PMF of this distribution holds the formula x plus r minus 1, c r minus 1, c is combination, p raised to the power r, q raised to the power x. Now substituting the values, x is 7, r is 3 minus 1, r minus 1 is 3 minus 1, p is 0.3 raised to the power r is 3, q is 0.7 raised to the power x is 7. 7 plus 3 minus 1 will be 9, and 3 minus 1 will be 2. 9c2, 0.3 raised to the power 3, zero point 0.7 raised to the power 7. We don't have to solve it further because the answers have been given in this format only. So this matches our option number A, 9c2, 0.3 raised to the power 3, zero point 0.7 raised to the power 7. Here 0.3 has the power 2, so this is wrong. Here 0.7 has power 6, this is wrong. Here both of them have power same, but here it is 10. So this is also wrong. That matches our option number A. Now this is also code matching problem. Here they have given the statements. From a consignment of manufactured items, items are taken out one by one with replacement. So x1 is the number of items drawn before the first defective turns up. X2 is the number of defective items obtained in n drawings. Number of drawings needed to get n greater than equal to defective. Number of defected items obtained in drawings when n is very large and proportion of defective is very. Now number of items drawn before the first defective turns up, x1. Before the first success turns up, the number of failures. So in the previous lecture we did, this is nothing but geometric distribution, where we talk about the number of failures before the first one turns up. And the second is number of defective items obtained in n drawings. Number of defective items obtained in n drawings is Poisson. When we are talking about x2, it is Poisson distribution. Then the third one is number of drawings needed to get n is greater than 2 defectives. When we are talking about the number of defectives in some particular in rth successes, then this will be r. This second one will not be Poisson because Poisson is nothing but the number of defective items obtained in n drawings. When n is very large, reaches to infinity, and probability is very small, then lambda is equals to n phi, which is finite. So x4 denotes that only, which follows our Poisson distribution. So x4 has Poisson distribution. So D matches with 2. D matches with 2. 1 matches with A matches with 3. A matches with 3. Now, if we see here, D matches with 2 has these two options. A matches with 3 has only this option, B option. So, our B option is correct by just solving these two. But let us solve rest others as well. If we talk about B, then B, number of defective items obtained in end drawings. If we are talking about the defective items obtained in end drawings, then it will be binomial only. And if we talk about the number of drawings needed to get n greater than 2 defective, that means we have some kind of defectives, which is failures, x, and we have some kind of successes, which is r. So we have these two, and this comes under negative binomial distribution. So x1, which is x2, which is B, matches with our option number 1, and C matches with our option number 4. So option number B, the code number B, A3, B1, C4 and D2 is the correct code for this particular given question. Okay, this was the statement wise question. Just knowing the concept will solve this. Now this is again the direct implementation of negative binomial distribution. If a boy is throwing stones at a target, the probability that his 10th throw is his 5th hit means the total number of throws, which is n, is 10. 5th hit means they have given the probability of success, which is P. They have given the successes, which is R, which is 5. Now, the number of failures would be the total number of trials minus the successes, which is 10 minus 5, and that is equals to 5 only. Now, the probability of hitting the target at the trial, which is probability of hitting the trial, has been given as 1 by 2. Then probability of not hitting the target will also be 1 minus 1 by 2, which is 1 by 2 only. Now, the PMF of this distribution is x plus r minus 1, cr minus 1, p raised to the power r, q raised to the power x. So x plus r minus 1, x is 5 plus r is 5 minus 1, c r minus 1, 5 minus 1, p raised to the power r, 1 by 2 raised to the power 5, and q 1 by 2 raised to the power 5. This is 5 plus 5, 10, minus 1, 9, 9c4. 9c4 can be written as 9 factorial upon 4 factorial into 5 factorial, and 1 by 2 raised to the power 5 into 1 by 2 raised to the 5 can be written as 1 by 2 raised to the power 10. Now further solving this here, if we solve them, it will be 9 into 8 into 7 into 6 into 5 factorial upon 4 into 3 into 2 into 1 into 5 factorial. These into 1 by 2 raised to the power 10. These two 5 factorial and 5 factorial will get cut out. 4 2s will be 8, 3 2s 6, and 1 2 will get cancelled to this one, and this will become 9. So it will be 63 upon 2 raised to the power 9, which matches are one of the option, and this has been given as one of the option, and it will match that, and that is your answer for this question. So this was all for negative binomial question. You just need to know the formula and different types of question I have explained. How would you solve them in examination? If you still face any doubt, then you can ask us in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.